Hello, let's continue our Sudoku adventure with Chompers by rockratzero. Is this a reference to the Mario Chompers that fall down like that? I think so. All right, so it definitely looks that way. All right, let's go over the rules. So we have thermometers in the grid. So that's these lines with a circle at one end. We call the circle a bulb because thermometer bulb. If you imagine those old mercury thermometers, maybe you're too young maybe to have seen those, but maybe not. All right. So anyway, the way those thermometers work is towards the bulb is a colder temperature, which is a lower number, right? So the lowest number is in the bulb, and then the number gets bigger as we move along the line. So it has to strictly get bigger. So if this was a 2, this needs to be bigger than 2. Like we could put 4, and we could finish off with 5, 6, which would be forced if we did 2, 4 like this. But we could also do like 1, 2, 4, 5 if we want, right? As long as they get bigger. What I can't do is 1, 3, 2, right? Because the 2 is smaller than 3. Can't do that. All right, that's thermometers. We also have these cages in the grid. These are not killer cages. These are look and say cages. First of all, digits can repeat in these cages. And the number in the top left corner should be read as a look and say number. So if you actually read out each individual number, 2, 3, what that's telling us is we have 2 3s in the cage. And this is saying we have 2 1s in the cage. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. I don't think the look and says are particularly useful right now. Okay, maybe they are because we need 2 1s in this cage. Now, the thing about thermos is you can't ever put 1s anywhere but the bulb, right? Because nothing can be smaller than a 1. So if I try to put a 1 here, what am I putting in the bulb? It's 0? Like 0 doesn't exist in this puzzle. So, and definitely can't put it here or here. Like there aren't 3 numbers smaller than 1. There's no number smaller than 1 between 1 and 6. All right, so these aren't 1, right? So I'm going to need 2 1s in this cage. And so I think, and I can only have one of them here because they share a row. So this is going to end up a 1. And then there's a 1 in one of these 2 cells, but I don't know if I can. I mean, maybe I'll corner mark that, but I might regret that later because it's not all in the same box. But well, I got to notate that somehow, so we'll try that. Now 2 3s. Do we have restriction on 3? See, I don't think 3 is very restricted here. I think any of these cells could be 3. Okay, so maybe we want to think about these longer thermos. We have a lot of 4-length thermos. So you can pencil thermos. Before I pencil them though, why don't we think about 1s and 6s? Because when we have this many thermos on the grid, it's usually beneficial. Like we thought about how these couldn't be 1, right? Let's think about that a little bit more globally. So this box is going to need a 1. And it can't be in a thermo. It can be on a thermo cell that's not a bulb. So the 1 actually ends up in one of these 2 cells in this box. Okay, yeah, I can actually just corner this and this because this box has the same thing. So we know where the 1s are either here or here, and that will fulfill our 2 1s. And also put a 1 in one of these bulbs. So that means that 1s aren't here, and they aren't here, right? We also don't have a 1 in any of these cells because of this one here. None of these are 1s. So I'm basically, why don't I just gray out anywhere that isn't a 1? I think that'll be helpful. This isn't a 1 either. Okay, and that's not a 1. That's not a 1 because of the 1 here. Okay, so 1 ends up in one of these 2. It ends up in one of these 2. And it's around this corner here. Okay, so I don't think we can do more with 1s than that. Why don't we think about 6s now? So 6 can only go in the tip of thermos, right? So 6 isn't going to go in any of these cells. It's not going to go in any of these cells. Definitely not in these. Only in tips. Okay. So 6 is going to be in these. I see. Okay. So we can't put a 6 in both of these cells, right? So we need a 6 in this row. It's going to be in one of these 2. Remember that there was also a 1 in one of these 2. So this actually ends up being a 1-6 pair. I guess we could have seen that just from the row, that in this row, 1 and 6 couldn't go in any of these cells. So the 1 and 6 end up here. Now here, this is a little bit interesting. 6 in one of these. I don't think I can do much with that actually. Is there anything else with 6s that's of note before I don't really think so. Okay, so we may have to end up doing the penciling I was talking about. So at least the 4-length ones. So if we count 1, 2, 3, 4, the smallest this can be is a 4 because we need 3 digits smaller than it, right? So this is 4, 5, or 6. And that's the same of all our 4-length thermos. Might as well put 4, 5, 6 there. Now these, level cooking actually worked, which is amazing. These ones are can be 1 less than the 4, 5, 6, so 3, 4, 5. They don't have to be 1 less, but you know what I mean. Like, we can't exceed 5 because then we wouldn't be able to put anything in the cell below it. And we can't get smaller than 3 because we need 2 cells smaller than it, right? So we can always subtract 1 from the candidates. 2, 3, 4, and then 1, 2, 3. Nice. And this 1 here says this bulb isn't 1. So by removing 1 here, that's going to propagate upwards because this can't be a 1 anymore, which means this can't be 2, which means this can't be 3, which means this can't be 4. This is going to be whatever digit doesn't appear on the thermo, but it could be any of them. So we can't say anything about that right now. All right, 2 in this box is in one of these 2 cells. Same thing here. Not sure if that's helpful right now. So this is a 1-2 pair, right? None of these can be 1-2. So this is a 1-2 pair. So now I don't think I need the ones in the corner marks there because the pairs are kind of telling me the same thing. That means one of these is a 2, which means one of these has to be a 1. I think we kind of already knew that because we know the ones aren't up here because of the way ones are make an X-wing here. All right, so there's something else I'm missing about this puzzle. Right, so we need 2 3s. Let's think about that now. They can't be over here. Right, so this has to be one of the 3s because these are all in the same box. We can only put 1 3 in here. There is a 3 in one of these 3 if you look at the box, but that means that the other 3 is here. So if that's a 3, this can't be 3, and this can't be 4. And this can't be 3. That can't be 3. Okay. None of these are 3. So that makes this a 4, 5, 6. Very nice. So that gives us, that resolves the 1 and the 6, the 2 and the 1. It resolves this 5 and 4. Wow, that resolves this all of this. Resolves that as well, and that. We get the 1 here. We get the 3 here. This is the 2 for the column. We get a deep 2 in the corner, by the way. That's a 2. That's a 1. That's not a 4. This is 5, 6. Wow, there's a flurry of digits all of a sudden. The 6 in this box goes here. This is 4 and 5. And the 4 tells us the order. This is not a 6. All right. Can't keep up with the cleanup here. These have to go in order. So this is 2 and 3. This is 5 and 6. So that's 6, that's 5. So that 5 there. All right, we know that this is 3 and 4, and they have to go in order. So that's 3, 4. That's 5 and 4. That's 6 and 5, and we finish with a 6. Nice. Just all of a sudden, just one deduction and everything, everything resolved. We did set ourselves up for success there, though. All right. Very neat. So yeah, as soon as I got that this was a 1-2 pair, that resolved everything because we needed 2 3s in here, and that made this a 3, and that just resolved everything. This single 3 here, that's kind of neat. So cool puzzle, Rock Rat. I enjoyed that. And if you did, then why not leave a like, subscribe, and a kind comment below.